Hi, everybody. Today we are going to be reviewing topic 3, and tomorrow, Thursday, we will be taking the topic 3 assessment. I have a lot to cover today, and I only have 15 minutes to do it, so I'm going to jump right into this. I'm going to go through each section, starting with topic 3, section 1 on exponents. Just as a refresher, when you're looking at a power, like here I have 2 to the third power, this is known as a power, this entire thing. The base is the number we're working with. We're working with the number 2 here. And then the exponent tells us how many times that base of 2 appears as a factor. 3 times. So 2 to the third really means 2 times 2 times 2. We're working with the number 2. It appears 3 times as a factor when we list it out like this as a repeated multiplication problem. And so we have a value of 2 times 2, which is 4, times 2, which is 8. So 2 to the third power equals 8. So if I went through a couple more examples, 5 squared, the mistake people make is they think it's 5 times 2, but it really means 5 times 5. We're working with the number 5 here. So it has a value of 25. 4 to the third power means 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So 4 to the third, no, it's not 4 times 3, it's not 12. It actually equals 64. We're working with 4, that's our base, and we have 3 of them. It appears as a factor 3 times. 4 times 4 times 4 is 64. And now I have 12 to the power of 0 here. That equals 1. So just as a reminder to all of you, anytime you see an exponent of 0, it has a value of 1. And in fact, I want to show you something here quickly. Take a look here. 2 to the third power, we just did that a little bit ago. It equals 8. It's 2 times 2 times 2, which is 8. What if I have 2 to the second power, 2 squared? Well, that just means 2 times 2, which is 4. What if I add 2 to the first power? Well, that's just 2. We only have it once as a factor, so its value is 2. Do you see how each time my answer, I can get from one answer to the next by dividing by 2? Dividing by 2. If I were to divide by 2 again, what would that equal? What's 2 divided by 2? Well, that's equal to 1, isn't it? So take a look here. 2 to the power of 0 then must equal 1, because that's what you get if you take 2 and divide it by 2. And that will work even if you used a different base other than 2. Anything to the power of 0 equals 1. So if you have 3 to the power of 0, that's 1. If you have 15 to the power of 0, that's 1. If you have smiley face to the power of 0, that's equal to 1. Okay, and if you have a number that's to the first power, like 3 to the first power, that will just equal the number that you're working with, 3. 15 to the first power is 15. Smiley face to the first power is smiley face. Okay, so hopefully you get the idea of how that works. All right, next thing I want to review is greatest common factor, that's GCF, least common multiple, LCM, and prime factorization. First of all, what are prime numbers? If I want to list the first 5 prime numbers are numbers that have exactly 2 factors, 1 and itself. So my smallest prime number is 2, and in fact, that's the only even number that would be prime. Its only factors are 2 and 1. 3 would be the next smallest prime number, and then 5, and then 7, and then 11, and it would keep going after that. Notice I skipped the number 9 because 9 is not prime, because 9 can be divided by 1 and 9. Those are its two factors, but it also has a factor of 3. 3 goes into 9, so it has more than 2 factors. Composite numbers are the ones that are composed of prime numbers. when you multiply them together. So composite numbers have more than 2 factors. Our smallest composite number is 4. And actually, every even number is composite except for the number 2, of course. So we have 4, 6, 8, 9 would fit in this list, though. There's an odd number that snuck into the composite list. 10, and so on and so forth forever. Those are your lists of composite numbers, okay? And now, prime factorization, just to review that, what is the prime factorization of 80? Well, I want to list nothing but prime factors that multiply together to equal 80. And so what we do on this number here is we want to use what's called a factor tree in order to find our prime factorization. So I'm going to do this here and figure out what times what equals 80. And we have options. Since it's even, I'll just do 2 times 40. That seems the easiest. And then 2 is prime. And then I have to break apart 40. And what times what would equal 40? Again, you have options. You could do 2 times 20. You could do 4 times 10. You could do 5 times 8. Any of those would work. Let's try 2 times 20. I'll put 20 times 2 here. 2 is prime. I'll circle it. And now the 20, we can split that apart. That's 10 times 2, right? 2 is prime. And 10, we can split that apart. 2 times 5. So my prime factorization is 2 times 2 times 2 times 2 times 5. Now, honestly, look at all these 2's here. Can't I show repeated multiplication using an exponent? I have 1, 2, 3, 4 of those 2's. So I could write 2 to the 4th power times 5 and write my prime factorization that way. I actually like that better because I don't have to list out all of those 2's since there are so many of them. So that's prime factorization and how to find it using a factor tree. All right, now GCF and LCM, greatest common factor, least common multiple. We could use factor trees to find these, but I think it's usually easier just to go ahead and list all of the factors to find the greatest common factor. So if I'm looking at the number 12, what are its factors? And I can list these out as what I call product pairs. The easy one, of course, would be 1 times 12. But then it's even, so I could take 2, and 2 times 6 is 12. 3 works also. 3 times 4 is 12. All right, so my factors of 12 are 1, 2, 3, 4, 6, and 12. You can find them all there if you just go around in a U. Okay, for 16, let's list all of the factors of that. We have 1 times 16, 2 times 8, and then we 3 doesn't work, but 4 times 4 works. I don't have to list 4 twice. Once will do. And its factors are 1, 2, 4, 8, and 16. You have them in order if you go around in a U. What are the common factors? Well, they have 1 in common. They have 2 as a common factor. They have 4 as a common factor. 6? No. 12? No. So we have 1, 2, and 4 are the common factors. The greatest common factor would be 4 here. Now, to find least common multiple, we do that a little bit differently because we have to list out multiples of 12 and 16. Multiples are what you get when you multiply the number by 1, by 2, and so on. And so 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, times 4 is 48, times 5 is 60, and we can keep going forever. It's what you're basically counting by this number, 12, 24, 36. 16, I can do the same thing, 16, 32, 48, 64, and so on and so forth. I'm noticing 48 is in both of these lists of multiples. And it's the first one that appears that's in both of these lists. So my least common multiple here is 48. Okay? All right, now very quickly, what number is both a factor and a multiple of 40? What number is both a factor and a multiple of 40? Well, that would be 40 because 40 is a factor of 40. It goes into 40, but it's also a multiple of 40 because if you multiplied 40 times 1, you'd get 40. So if you want to know what number is both a factor and a multiple of a number, what's going to be that number itself? All right, numerical expressions. Um, when we solve numerical expressions, we just want to do our order of operations, follow our order of operations. Look at this example, 6 plus 4 times 5 minus 16 divided by 2. All right, so what I need to do here is decide, what am I going to do first? Add, multiply, subtract, divide? Well, we do our multiplying and dividing before we do our adding and subtracting. So I have to take 4 times 5. I also have to do 16 divided by 2. 4 times 5 is 20. 16 divided by 2 is 8. So now what I have is 6 plus 20 minus 8. And now adding and subtracting we just do in order from left to right. 6 plus 20 is 26. 26 minus 8 is 18. There's my answer. That's how you simplify or evaluate a numerical expression. Look at this example here. Now parentheses, I need to do those before I do anything else. 8 minus 2 is 6. 2 times 4.5 is 9. So I have 3 times 6 divided by 9. And then I just do the multiplying and dividing in the order they appear from left to right. 3 times 6 is 18. 18 divided by 9 is 2. There it is. So those are pretty easy to do. Just follow your order of operations. You can always go back and review this, do this video again if you aren't sure how to do anything. All right, algebraic expressions. We need to talk about what terms are. Terms are separated by plus signs and minus signs. So how many terms are there in this expression? We have one here, and one here. They're separated by these minus and plus signs. So we have 3 terms here. This one over here, we have a term, here's a second term, here's a third term, here's a fourth term, all separated by the plus and the minus signs. So we have 4 terms here. So we need to know what terms are. Okay, now if you're evaluating algebraic expressions, I'm moving quickly here because of time. What you want to do here, I have 6w, which means 6 times w, divided by x, plus 9. We can substitute values in. T equals 8, W equals 1/2, X equals 3. We're going to evaluate or find the value of these when we substitute these in. So 6 times W, I like to use parentheses to show multiplying. W is 1/2. So I have 6 times 1/2 divided by X. X is 3 plus 9. What is 6 times 1/2? Well, that's the same thing as 1/2 times 6 or 1/2 of 6, which is 3. So I have 3 divided by 3 plus 9. Then I divide next. 3 divided by 3 is 1, and then 1 plus 9 is 10. See how easy that is? So you just plug in the values and solve. All right, I'm going to have to jump to the next part here if I'm going to get this all done in time. All right, generating equivalent expressions, topic 3, section 6. Write an equivalent expression for the following. This is where we use the distributive property. When we see 4 times the quantity 2a minus 8, I have to, remember when I talked about what I like to call bombing the fort? So we do that here. We take 4 times 2a minus 4 times 8. We must multiply by both of these terms inside of this quantity. So 4 times 2a is 8a. And then, of course, it won't write for me. There we go. Minus 4 times 8, which is 32. Sometimes people will ask, well, can I just skip this middle step and just go right to the 8a minus 32? Yeah, you can. All right, 4a plus 2b. Now this one, I don't have anything times a quantity. I have to go backward this time. It's like I'm taking an answer and working back to what we started with. So I look here and I can divide them both by 2. So I have 2 times the quantity 2a plus 1b, or just 2 times the quantity 2a plus b. I'm about out of time, so that's going to be it for today. Good luck on the test tomorrow. Review this if you wish.